we should make everybody, okay, everybody raise your hand, make sure your right hand works. Raise your hand up, good. And after this, I just, for those people that have to rush off, I realize you do, but there is a conference called Bioengineering Insights. And the 2 afternoon sessions, one I know is in biomaterials, the other one I believe is in detection and diagnostics. If you're interested, come tell me, because following that there's a great reception with a bunch of posters. And normally we have a reception, but since we embedded this in the conference, we'll be. So not least, but most especially an important kind of final presentation having to do with what is going on. We had a number of companies want to hear some updates in what's going on in computer science. So Chandra Krintz from the computer science department is a professor who has spent a lot of effort in the wave of the future. So
thank you very much. Yes, thank you all for coming and for allowing me to speak and tell you a little bit about what we're working on in computer science. Particularly in terms of our curriculum for our undergraduates. And so that's what I'm here to tell you about today. Our goal is to produce the next generation of the top researchers, technologists, and entrepreneurs. Now, like all the departments in the College of Engineering, we are very much focused on research, and what we've found and have continued to find is that the way we can contribute to undergraduate curriculum and education really is grounded in the research that we do in our department. We have really high impact, high visibility software and hardware systems that we work on, everything from security to cloud computing to large-scale data manipulation to energy-aware hardware and software. And so what we can do is we can use these efforts to bring new ideas and ways of thinking to our undergraduates in terms of the classes that we teach. It also gives our students the opportunity to work on real projects, cutting-edge research in computer science. It also helps, we found, in terms of computing. This is just a small blurb taken from the blogosphere. It's talking about some of our recent advances and contributions in cloud computing, and now how he's going to send his kids to the computer science department at UCSB. So we have a lot of ways in which we're dedicated to the undergraduates in our curriculum. These are just a handful of the recent changes, and they all really evolve into this restructuring that I'm here to talk to you about today. In particular, we've hired 2 lecturers with security of employment. Now this is important because, again, our faculty are research faculty, and we're focused on our research contributions. So we can teach, but we're not, our key focus, our only focus has not been education. And so by hiring 2 lecturers who are experts in teaching and computer science education processes, we think we've made an investment in the future for our teaching. The security of employment is an interesting position in that the lecturers, it's like tenure. It is a permanent position. So that way they're invested in the long term in our department, in our educational processes, instead of having a temporary position that has to be renewed every few years, a very short-term outlook. Our faculty, as I said, in addition to being great researchers, are also really great teachers. In the past 6 years, we've won 4 UCSB-wide Distinguished Teaching Awards. So our energy does go into our teaching, and so that's really important. I think you have to have that at the same time as you're redoing your curriculum to make a big impact. We also involve our undergraduates, as I said, in our research projects. So the restructuring itself is of just the lower division. This is the first 2 years. We have thoughts and longer-term visions of starting to impact the upper division, but we wanted to do this in incremental steps, in stages, so that we could do evaluation and figure out if we're making the right decisions, and then act accordingly. Our previous curriculum, we've been using for many, many years. There was lots of great things that were part of it that we wanted to hold on to. There's a lot of things we wanted to change as well. Just to give you a sort of a sampling of what that looked like, it was about a year of programming in Java, focused on the Java programming language. And we had a class on computer organization and digital logic, that's assembly and digital logic design. We had some foundational concepts of theory, background in computer science. And then at the very end, we had a one-quarter project one-quarter class that would introduce the low-level languages, C, C++, and the Unix operating system, all in 1/4 of 10 weeks. So our observations were from this that, again, there were some really strong pieces of this that we wanted to maintain, but we also wanted to think about what maybe are some the issues that were arising from this curriculum. Big one was recruitment and retention. We wanted, as you all probably know, the admissions, the number of applications to computer science has been on the decline. It's only starting to level off now. And so we wanted to have some sort of way of attracting students to our program, top students. Our attrition rate, our retention rate was poor, or we were losing students more and more, and we wanted to understand why that was. And these students typically were great students, but they came from diverse backgrounds. So we wanted to understand that better and try to ensure that we had a broad participation in our departments in terms of the student body. This is really important for innovation, we believe, and to have different perspectives for the next generation of computer science. We also did you'll see a 2-year study of past students, our current students, industry partners, people who hired our students, people who didn't hire our students, other departments around the United States that would take our graduates for graduate school. And we looked to them to provide us with feedback on what was good and what was bad about our curriculum. We found that there was a lot of feedback that said that our students were just ill-prepared for when they got out, and a lot of the comments about the students within the program were that they weren't prepared for the upper division. So that's why we've really focused on the lower division to start out. The key thing in terms of being ill-prepared, I just want to clarify, is that they could program in Java, well, a high-level language, but they didn't have a fundamental understanding about how the program was interacting with the hardware underneath. And that was really key to taking on new languages, to understanding, to be able to go in different directions, such as, the gaming environment or low-level computer engineering positions. And so we really wanted to sort of broaden the opportunities that were available to our graduates. A lot of the companies also gave us feedback that they would really like to see some of the modern software engineering technologies, both in terms of tools and as well as in terms of processes. So things like making sure that the students understood how to use debuggers, novel integrated development environments, vast library supports, but also did things like could work in a group, could communicate well their ideas and about the things that they were working on. Also, lots of companies use lots of different programming languages. There isn't one, Java isn't the answer, and so we needed to be able to produce students that had the ability to go between lots of different languages no matter where their future took them. So our revamp, our restructuring process, we spent about 1.5 to 2 years doing these interviews and this evaluation, this reflection on our curriculum and where we really wanted it to go. We did our new faculty hires and as well as our new lecturer hires I mentioned. And then we produced a proposal and had discussions about the proposal as a faculty for quite a long time about the structure, about the topics we wanted to teach, as well as the pedagogical tools that we wanted to include. And finally, once we came up with this proposal along with an evaluation plan, that took about a 1.5 years, and then it finally was approved last year. And so this is the first year that we've started to implement this new curriculum. So it's the first, we're implementing 1 year of it, and it'll be in full swing next year for both years, year 1 and year 2. Again, our goals are just to address the limitations that we observed from our interviews and our reflection on our current curriculum. Better prepare students for upper division curriculum, research, careers in industry, improve recruitment and retention. A key benefit here, or key observation we made here from other successful programs, were that we really need to employ more real-world problems. We needed to have more emphasis on problem